Hi students, welcome to this channel. We are studying Standard 9 Physics, in that Chapter 8, that is Motion. This is the part 2 of the chapter series, and in previous video we have studied the introduction topics. Now we started with introduction part, introduction of what is motion. We have discussed many examples. Then we have studied different types of motion. What are the various types of motion which we are observing or which we know about it in our daily life, from our daily lives. We have studied different terms related to motion, how to describe the motion. Then we went for distance and displacement, two very important terms related to motion. And our previous video, that is part 1, ended up with what is uniform and non-uniform motion. Now in this video, that is part 2, we will study about, let us quickly note down what are the today's topics. Now in this video we will be talking about three very major terms and concepts related to motion, and that is speed, second one is velocity, and the third one is acceleration. Now these three we'll be studying in detail in this whole chapter, as the study of motion mainly depends on these three things. Now in these three topics there are few subtopics which are very important to study. In speed we have uniform speed, non-uniform speed, average speed. Same as speed, in velocity as well we'll study uniform velocity, non-uniform velocity, average velocity, and lastly we'll study the concept of acceleration. And there is another topic which is important and which is related to acceleration, that is retardation. Actually retardation is opposite of acceleration, right? And then we'll study examples related to each of these concept examples. In the terms, we will study various numericals related to these three terms. So let us see one by one what is the importance of these terms. Now friends, let us go ahead with the next topic, that is rate of motion. We'll quickly come towards those three topics. Now you can see two of the circles over here. In the first one I have written some words, in the second one I have written some words. Now can you find a small difference, a very common small difference in between these two, right? In first I have written bullet train, sports car, cheetah, Usain Bolt, and in the other one I have written memu train, a kind of train which runs slowly, bus, van, normal athlete, horse, etc. Right? So if we carefully study these examples, we'll conclude that what is the difference? One group is very fast moving object and another group is comparatively slow moving object, right? The first one is fast moving objects, and obviously it includes normal people and animals as well. So fast moving and slow moving, right? So you have to stress upon the word fast and slow, right? Normally in other examples as well we come across various concepts, like if you are watching cricket, while in over they give bowling speed, right? So if a bowler is fast bowler, let us assume that it is 145 kilometer per hour speed they are giving, right? Even in some roads where there is an important buildings nearby, you can see that they are putting some labels and boards like this, and they are writing speed limits, right? Like what is the speed limit nearby school? So don't cross the speed limit 30 km per hour, right? So they are putting speed limits, right? So common words over here to put stress upon is, first of all, fast, slow, right? Different objects, they move with different speed, right? So a very important word over here is speed, right? That is why I have put the title rate of motion, right? Rate of motion means different object may take different amount of time to cover a distance, right? So the rate at which they cover the distance might be different. Accordingly, if any thing or any animal, let us say cheetah, it covers the distance in very less time, so it is called fast. And if the distance is covered very in a very more amount of time, so that is called slow, right? So what is speed? It is the ratio. What is speed? It is the ratio of distance covered by any object with time, right? So that is why we are telling it as rate. What is speed? Speed is distance covered per unit time, right? In definition you may have to use unit word, right? So if we denote speed as nu or v, distance as s, and time as t, so we have the formula speed is equal to distance upon time, right? Now if you put for a unit, if let us take the standard units, right? So standard unit of distance covered, what will be the standard unit of distance? That is meter. And what will be the standard unit of time? That is second, right? So speed is measured in meter per second. Other units can be there. Other units are, if you convert this as a bigger one, so meter converts into kilometer, second converts into hour, right? We can have centimeter per minute as well. Likewise we can have other units, but standard unit will be meter per second. Few points to remember: that speed is a scalar quantity. What is a scalar quantity? Quantities which require only magnitude for complete description is called scalar quantity. Speed, as we know, distance is always positive, so speed will always be positive. So we'll write speed is always positive, right? So few points to take care about. Now whenever we are studying any new concept, we'll have to write the definition. So you will put the title speed, you will write the definition in words, right? Speed is the ratio of distance covered by an object per unit time. Then you will write the formula in words as well as in the symbols. You will go for the unit. First of all, you will write the standard unit, and then you will go for other units, and few important points to be taken care of. Now moving ahead in speed topic, what are the three different subtopics in this? So we have already discussed that uniform speed, non-uniform speed, average speed will be the subtopics. Now quickly, as we have already studied what is uniform motion and non-uniform motion, we'll relate that with speed. So there are two topics, uniform speed or non-uniform speed. So I'll be explaining you what is uniform speed, and we'll write in short how can you understand about uniform speed. Now if a moving body covers equal distance in equal interval of time, remember, equal distance in equal intervals of time, that object is said to be in uniform speed, right? So in uniform speed, the object is covering equal distance in equal intervals of time. So the opposite of that will become non-uniform speed. So here, if a moving body covers unequal distance in equal interval of time, then the speed is said to be non-uniform. So here we have the object covering unequal distance in equal amounts of time, right? So if it is unequal distance, it is called non-uniform speed. Now there might be some intervals or examples in which we study speed. An object took this much time to travel this much distance, it stopped, and then again it started its journey for some distance and for some time, and again it started its journey for some distance and some time. So 3 times the object has started its motion and stopped, right? So what if you want to know overall for all 3 incidents what was the average speed? Likewise, if I give another example, if you want to go Delhi, right? So you won't be starting from your home and go to Delhi continuously, right? So if you do that, you can have the information related to speed. But what we are doing actually, we are stopping at few distances, right? For few amount of time we are traveling, then we are stopping, then again we are traveling, then again we are stopping. So likewise for different instance, if you want to have an information on average journey, you will be finding average speed, right? So not going into much detail, as I have explained, we will write average speed in very short. Average speed is the ratio, right? Average speed is the ratio, right? As you know, speed is the ratio of distance upon time. But if you are finding average speed, you will have to include the word total distance upon total time. Now, just like speed was used to determine the rate of motion, we have another physical quantity called velocity, which will also determine the rate of motion. The only difference is that in speed we took distance per time, but in velocity is, first of all, what is velocity? It is the ratio of displacement done by the object per unit time, right? So here only one word is changed, and that is displacement, right? As in speed, per unit time was also there. Whenever we use rate, that is per unit time, but here in velocity we have displacement per unit time, right? So what will be the formula of velocity? Velocity equals to displacement per unit time, right? If we talk about unit of velocity, right, displacement unit and time unit you have to take. So what is how we are measuring displacement? Again, displacement is change in position. So change in position, we are using unit like meter, kilometer, etc., right? Just like distance. And time, we have second. So what is the official SI unit? Displacement is measured in meter and time is measured in second, right? We have other units as well, like kilometer per hour, centimeter per second, etc., right? But the standard unit will be meter per second. Now few things to take care, as velocity of any object is related with direction, right? Velocity is related with direction, so it is called a vector quantity, right? Because we need magnitude, the value, plus we also need the direction, so that is why it is called a vector quantity. Now if displacement, we have studied that it can be positive, it can be zero, it can be negative. So in case the velocity will always be, velocity can be negative, positive or zero. Zero, if displacement is zero, zero upon anything will become zero, right? So few points to be taken care of, that velocity needs direction, so it is a vector quantity. Velocity can be negative, positive or zero. SI unit of velocity is meter per second. Now the subtopics related with velocity, as we have studied in speed as well, uniform speed, non-uniform speed, average speed. Quickly, let us go through what is uniform velocity. First of all, it will be uniform velocity. What is uniform velocity? So in speed, it was if the object is moving or doing equal displacement, equal distance, covering equal distance with equal interval of time, it was uniform speed. So here velocity, so we will write equal displacement in equal interval of time, equal intervals of time. So here this will be uniform velocity. What about non-uniform velocity? Can you make your own definition of non-uniform velocity? Can you guess? Yes, it is if the object is doing unequal displacements. If the object is doing unequal displacement in equal intervals of time, it is said to be in non-uniform velocity, right? So what is the last portion left? What is the last portion left? It is average velocity, right? It is average velocity. Now in short, what will be the average velocity? So it will be average of the displacement upon average time. So in short, if you want to write what is average velocity, it will be total displacement. It will be total displacement upon total time. In average speed, we have seen total distance upon total time. So average velocity will be the ratio of total displacement upon total time. As the word average is used, we will be using the word total, right? And guess the unit. What will be the unit? The unit of average velocity will again be the same, because displacement is in meter and total time is also in second. So it will be meter per second only. Friends, average velocity can also be found by a new method, which I am going to write just now. In case if initial velocity and final velocity of any object is given, right? If initial velocity and final velocity of any object is given, then also you can find average velocity. Instead of that original formula, total displacement upon total time, we can have another formula as the average of the velocities, that is initial velocity plus final velocity upon 2. So this will give the average velocity, right? So we have another formula for finding average velocity as well, and that is initial velocity plus final velocity upon 2. Now let us understand the concept of measuring speed and velocity by a very easy example, right? We are solving a numerical in which the question is an object travels 14 kilometers in 2 hours. Find its speed in kilometer per hour and meter per second. So in this question, please keep in mind we are also finding how to convert kilometer per hour into meter per second, right? We will focus on what is given. The first information that is given is 14 kilometers, so that will be the total distance, and another information we have been given is 2 hours, that is the time, right? So quickly let us write. Whenever you are solving a numerical, always read the question, try to understand that, and try to find out, try to extract what hints are given, right? So hints given are what is the total distance and what is the total time. So what is the distance over here? 14 kilometer, and time is 2 hours. What we are finding is speed, right? What we are finding is speed. So let us write the formula of speed. Speed equals to distance upon time. Put the values. What is the distance? 14 kilometer. And what is the time? That is 2 hours. So 14 kilometers and 2 hours. So that will be 2 ones are 2, 2 sevens are 14. So our final answer is the speed is 7 kilometer per hour. Right? What is the speed? It is 7 kilometer per hour. But now we have a very important conversion. This is the first part of the answer. Find its speed in kilometer per hour. We have the first answer, that is 7 kilometer per hour. Now let us convert this value kilometer per hour into meter per second. That is very easy. I'll explain it. Now to convert kilometer into meter, you just have to know the relation between kilometer and meter. 1 kilometer, how many meter? So that is 1000, right? And 1 hour, how many seconds? That is 60 into 60, right? Hour into minute, minute into second. 60 into 60 becomes 3600. So if you want to convert kilometer per hour into meter per second, you just have to multiply that number with 1000 upon 3600. So let us convert 7 kilometer per hour into meter per second. So 7 kilometer per hour is 7 into 1000 upon 3600. You can always cancel it. 2 zeros can directly be cancelled, right? So we have 7 into 10 upon 36. Again, if you want to cancel 10 and 36, you can do that. 2 5s are 10, 2 18s are 36. Now we are seeing that we don't have anything to cancel in numerator and denominator. So what we'll do, we will be multiplying the numerator, that is 7 into 5, 35 upon 18, right? Meter per second. So 18 2s are 36. You can see we have almost a number which is twice than 18. So our answer can be, right now I'm not doing exact calculation, our answer can be 1.9 meter per second or 2 meter per second. Here I have another question, and that will be a part of homework for you. Just now we have solved a question. I am giving a question similar to that. You can easily find the answer. The question is, an object travels 36 km in 2 hours. Find its speed in kilometer per hour and meter per second. So follow the similar instruction and calculation just now we have done, and find out the correct answer and write in continuation with that numerical in your notebook. Now here we have another question. An object travels 14 km in 4 seconds and another 16 meter in 2 seconds. Right? This is 4 seconds, this is 2 seconds. Right? It is not 25, it is 2 seconds. Now we have to find out what is the average speed. Right? Do you remember what was the formula of average speed? Yes, it was total distance upon total time. Right? Now why we are finding average speed is that I have already told that whenever the object does multiple motions in multiple time, we are finding average speed, that is overall speed, right? So let us quickly start with the first step of solving the numerical, that is finding out what is given. So first is 14 meter, that is distance, 4 second, that is the time. Another 16 meter is second distance, and this one is second time. So let us name the distances so that we will be calculating that very easily. Right now I am putting first distance as S1, that is 14 meter. First time as T1, that is 4 seconds. Same way we have S2, second 16 meter, and then T2, that is 2 seconds. Right? And now can you find out what is the total distance and total time? Yes, we can add them and then we will easily able to calculate. So starting with what is the average speed formula, that is total distance upon total time, right? So putting all the values, s1 plus s2 upon t1 plus t2, so that is 14 plus 16 upon 4 plus 2. What is 14 plus 16? It is 30 and 4 plus 2 is 6. So if you cancel it, you will get the answer, that is 6 5s are 30. The average speed was 5 meter per second. What we did, we just added up the distance and added up the time. So total distance upon total time, that is 30 upon 6, that is 5 meter per second. So that is how you are finding average speed. So a similar question is kind of homework for you. Again, in continuation, you will be solving this. An object travels 25 meter in 4 seconds and another 50 meter in 6 seconds. What is the average speed? Now, moving on to another special question. Here we have Usha, who swims in a 90 meter long pool. She covers 180 meter in 1 minute by swimming from one end and back along the same path, right? You have to take care what information is given. Usha is swimming in a 90 meter long pool. She is going from one end to another, right? Suppose take this as the swimming pool. She may starts from here. She is moving like this 90 meter and goes back in the same path, right? The length of the pool was 90 meter, right? Why I am telling this as special example, because you are finding average speed as well as average velocity. So we have a common starting and common ending point. Now let us go for what is average speed, right? Let us quickly make the given information. Given is the total distance, that is 180 meter. Time taken is 1 minute, and 1 minute we have to convert it into seconds, so it is 60 seconds, right? So what is average speed? Average speed is total distance upon total time, right? So total distance is 180 meter, total time is 60 seconds. So 0 0 cut, 6 1s are 6, 6 is 18. So average speed was 3 meter per second. So here we have our first answer, that is average speed is 3 meter per second. Now let us go for average velocity. Now here you have to apply a little bit of common sense, right? Average velocity is total displacement upon total time, right? Now if Usha is starting from this point, going 90 meter over this point and coming back to the same point, what will be the total displacement? She is starting and ending at the same point, so she haven't displaced at all. So here we have displacement as 0 meter. Time taken is 60 seconds. So overall answer is 0 meter per second. Again I am telling, average velocity is total displacement upon total time. As Usha is starting at a point, and even after she goes and swims a lot, she is ending up with the same point. So what will be the displacement if she starts and ends at the same point, right? So she doesn't displace at all. So displacement in this case will be 0 meter, and 0 upon 60 is 0. So what is the average velocity of Usha? It is 0 meter per second, right? So students, we are stopping right now. We have discussed speed and velocity and its related contents. In the next video we will be studying about acceleration, that is again a very important term, and retardation, that is opposite of acceleration. And we will also study further numericals in the next video. That will be part 3 of this. So till then, stay tuned.